Today's lesson is on repeated synthetic division. This is a process of just doing synthetic division over and over again, just as the title suggests, and it can be used to determine if solutions, roots, zeros, whatever you'd like to call them, satisfy a particular polynomial. So as you can see, the first bullet point says it can be used to determine if numbers are zeros to a polynomial. We've got our first example down here. Feel free to always pause the video to write down whatever you need and come back when you're ready. So we're going to show by repeated synthetic division that -2, -3/2, and 1 are zeros of the polynomial p of x in factored form. So there are multiple ways to show that the roots of -2, -3/2, and 1 are the roots of this polynomial. We could graph it and see if it crosses at those three numbers. We could sub each of those numbers into the polynomial p of x one at a time to see if it makes the equation equal 0. Or we can do this process here, repeating synthetic division. So the way you do it is you test out one root at a time. So it doesn't matter which root you start with. So I'll just start with -2 because it's first. So I'll put -2 out here, and I'll do my synthetic division by taking the coefficients. Again, if there's ever a term missing, make sure you hold a place value with a 0. Here we don't have that. It's 3, 2, 1 constant, so we're good to go. So 2, 5, -1, and -6. And again, this little vertical line here, you can put it there or not at this point. It's up to you. It just kind of reminds you that that number in this area is a remainder. So we bring down the first term. We multiply, we add, and feel free again to stop the video at this point and just do the synthetic division on your own and then check back with me when you're done to see if you're right. So -2 times 1 is -2, add up to -3. -2 and -3 add up to 6, and we get a remainder of 0. So since we get a remainder of 0, it's telling me that this root evenly divides into the polynomial, which means it's definitely a root. So that validated it. Now, when you're doing repeated synthetic division, what you can use is this new equation that's formed, which it would be x squared plus x minus 3. We can use the coefficients of this equation to do synthetic division with the next root, -3/2. It just makes it a little bit easier and a little bit faster now. So if I just take the next root, which is -3/2, don't be afraid, it's a fraction, it's all right. And I can just use the coefficients of the, I forgot the 2 up here. Did you notice that? I forgot the 2. So I can use the coefficients of this new equation because it just makes it faster as opposed to using the original one. So I can use 2, a 1, and a -3. So bring down the 2. -3/2 times 2, guys, that's easy. The 2's would cross cancel, so you're just left with -3. Add it up to be -2. And again, -3/2 times 2, the 2's would cancel, and the 2 negatives would cancel, making it a +3. And again, we get a remainder of 0. So if this root evenly divides in, getting us a remainder of 0, it proves that yes, it is a root. And so lastly, we'll just try the last root, which is 1. And of course, I can use this new equation here, which is much smaller. So if we start with an x squared, it's going to go down to an x term, 2x minus 2. So I'll use those coefficients here, 2 and -2, makes it nice and easy. So bring this down, 1 times 2 is 2. That makes a remainder of 0. So this tells me, since they all evenly divided in, that they are all definitely roots. Now the question also said to write this answer in factored form. Remember, these numbers here are our roots, solutions, x-intercepts, whatever you want to call them. They're the place where they cross, where the polynomial crosses the x-axis at these three numbers. So to write it in factored form, we just write, well, where did x minus 2 come from? It came from x plus 2. Where did x minus 3/2 come from? X plus 3/2. And lastly, where did the positive one come from? It came from x minus 1. And you can set it equal to 0 or p of x. I set it equal to 0 since we're talking about roots. Now, just because that fraction looks a little ugly, you could, if you wanted to, just multiply this part right here by a 2. So bring down the x plus 2. If I multiply this by a 2, it would knock out that 2 just to make it look nicer. So 2x plus the 2's would knock out 3. Bring down the x minus 1 equals 0. So this is what's called the factored form. These can also be called factors. The 3 root solutions, x-intercepts, could also be called the factors, and this is the factored form. So what you're going to do next now for homework, if you will, this part wasn't explicitly shown in the textbook, so I'm just creating some problems for you guys to try on your own. You can stop the video and copy these down. You'll know if you're correct because these should work. The directions say show the following are roots of the polynomial shown. So it's telling you they're roots. You just have to show it by doing the synthetic division repeatedly. And like I said, they are roots. So when you do it, you should continuously get the remainder to be 0. And if you don't, shoot me an email. Maybe snap a picture of what your work is, and I can try to look at it and see where you are going wrong. So have fun with that, and we'll check in tomorrow.